are going to learn about the wave motion. This chapter will give you an idea regarding different types of waves, sound and its characteristics, acoustics of buildings and seismic waves. Before moving on to the lesson, let us first revise some terms which you have already learned in the lower classes. First thing is wave motion. It is the propagation of disturbances from one place to another in a medium. The energy will be transferred from one place to another. Example, sound waves. Now, let us see the characteristics of wave motion. First characteristics, that is frequency. It is denoted by the letter F. It describes the number of waves formed in 1 second. The equation will be F is equal to number of waves, that is denoted by the letter N, whole divided by time, that is denoted by the letter T, and its unit is Hertz, denoted by Hz. Next one is period. The time it takes for one complete wave to pass a given point, that can be measured in seconds. Now, the next one, that is wavelength. Wavelength, it is denoted by the letter lambda. It is the length of one wave or distance between two consecutive particles which are in the same phase of vibration. Now, the unit of lambda is meter, that is denoted by m. Then, amplitude, it is denoted by the letter A. It describes maximum displacement of a particle from its mean position or the height of the wave. Now, the next term is speed. It is denoted as V. It describes the distance travelled by the wave in 1 second. So, speed is given by V is equal to F into lambda. Its unit is meter per second. Now, let us see the types of waves. First type is mechanical wave. It is broadly classified into two. First one is transverse wave and the second one, that is longitudinal waves. The second type is electromagnetic wave. Now, let us see the difference between mechanical waves and electromagnetic waves. First difference is mechanical waves requires material medium for their propagation. In case of electromagnetic waves, do not require material medium for their propagation. Second point, mechanical waves form due to the vibrations of the particles in a medium, where in case of electromagnetic waves form due to varying electric and magnetic fields. Now, third point, in case of mechanical wave, speed of sound wave is low, that is 332 meter per second at 0 degree Celsius, that is in air, where in case of electromagnetic wave, speed of electromagnetic wave is high, that is 3 into 10 power 8 meter per second, that is vacuum. Next point, in case of mechanical wave, it can be transverse or longitudinal in nature, but in case of electromagnetic wave, it is transverse in nature. Now, take a look on this illustration. Here, the y-axis describes the amplitude and x-axis describes the direction of propagation of wave. And look into the graph. The upper limit describes the crest and the lower limit describes the trough, and the arrow represents direction of vibration of particles. Next one is longitudinal waves. Take a look on this illustration. Here, all waves are moving left to right direction, or waves pile up left to right, where in case of transverse waves, the waves pile up and down. Take a look on this. Now, let us see the difference between longitudinal and transverse waves. First point, the particles of the medium vibrate in same direction, where in case of longitudinal wave, but in case of transverse wave, the particles move at right angles to the direction of wave propagation. Second point, they are possible in all kinds of media in case of longitudinal waves, but in case of transverse waves, they are possible only in solids. Next point, the longitudinal wave consists of regions of compression and rarefaction, where in case of transverse waves, they consist of crest and trough. Next point, they cannot be polarized in case of longitudinal waves, but they can be polarized in case of transverse waves. The last point is sound waves in air is an example of longitudinal waves, and vibration in a string is an example for transverse waves. Now, let us learn about the compression and rarefaction. Compression is the region of high pressure, while rarefaction is the region of low pressure in case of longitudinal waves. Now, we are moving to the next topic, sound. Sound is a vibration that typically propagates as an audible wave of pressure through a transmission medium such as a gas, liquid or solid. Now let us see sound in detail. Sound can propagate through a medium such as air, water and solids as longitudinal waves and also as a transverse waves in solids. Next point, the speed of sound differs from one medium to another due to difference in the density of media. Now let us see the factors influencing speed of sound in air. Factors are humidity, density, temperature, pressure and nature of the medium. Now we are going to study about the characteristics of sound. Loudness is the sensation of hearing caused in an individual by sound. It increases with amplitude of sound wave. Unit is dB, that is decibel. The next point is pitch. Pitch is the sharpness of sound. It increases the frequency of sound wave. Now quality. Quality or timbre helps to distinguish between two sounds. Next point, intensity. Intensity is the quantity of sound energy per unit surface area in unit time. Its unit is watt and it is denoted by W per meter square. Now we are going to study about resonance. What is resonance? It is a phenomenon in which a vibrating system or external force drives another system to oscillate with greater amplitude at specific frequencies. Example, pushing a person in a swing. Next one is reflection of sound. When sound travels in a given medium, it strikes the surface of another medium and bounces back in some other direction. This phenomenon is called the reflection of sound. The waves are called the incident and reflected sound waves. The repeated reflection of sound from different objects are called multiple reflection of sound. Now let us see some applications. First one is megaphone, second one is stethoscope and the third one is soundboards. Move on to the next one, that is reverberation. Reverberation is the persistence of sound as a result of multiple reflections. Example, booming sound in empty rooms. Next an important term is echo. Echo is the hearing of a sound by reflection from a surface or obstacle after hearing the original sound. The next one is acoustics of buildings. It is the branch of science that deals with the conditions to be fulfilled in the construction of a building for clear audibility. Now let us see the methods done to minimize the reflection of sound. First one, make the floor and walls rough. And the second point is use carpets and curtains. The third point is provide more doors and windows. The next point is the proportion of length and height of the hall should be appropriate. Next point is avoid curved walls. And the last point is wooden panel for walls and ceilings. Place larger number of chairs. Next type of wave is seismic waves. Seismic waves are waves of energy that travels through the earth's layers and are a result of earthquakes, volcanic eruptions and magma movement, large landslides and large man-made explosions that give out low frequency acoustic energy. Now let us see some important points that we have learned in this chapter. Longitudinal and transverse waves, then applications of resonance, reflection of sound, then characteristics of sound and acoustics and seismic waves. Now let us see some important questions. Here you have to find the solution. First question, what is the relation between wavelength and frequency? Hint given is inversely proportional. Move on to the second question. What is the phenomenon behind the sound of strings in a violin? You have to find out the answer. Third question is, mention the factors affecting the speed of sound. Fourth question is, what is the phenomenon behind the stethoscope? Fifth question, soldiers are not allowed to march across suspension bridges. Explain the phenomenon. Hint given is due to resonance. Friends, now this chapter is over. We will reach you on the next chapter. Bye.